Let's look at today's subtopic, efficiency. Efficiency is a measure of how much of the total energy that may be used and is not lost. In terms of equation, is useful work done divided by total energy input. So useful work done means we are using the system to harness the energy into something that we wanted to. So for example, a car engine, the useful work done is when it moves the car, the amount of energy that is used to move the car. And the total energy input will be the total energy that is provided by the engine of the car. So the rest of the amount of energy, for example, the heat energy and the sound, so those are the unwanted amount, and of course we want to avoid that and keep that to the minimum amount. Then we can say that the efficiency of the engine is high. So alternatively, it can be also defined as output power divided by input power. So another example here, you have actually looked at it when we discussed the case of water boiled by a boiling water by a Bunsen burner. Okay, in the discussion, you have pointed out different parts of the system where the energy goes into instead of the water. So the water will not get the 100% of the heat from the fire. So example here is like 4200 joule of internal energy. That's what the water gain. However, the electrical energy actually is supplying 10 kilojoule of energy. So therefore, if we use 4200, which is the useful work done, divided by 10 kilojoule, which is the input, then we'll get the efficiency of 0.42 or 42%. So you can always keep to a decimal number like 0.42 in this case, or you can keep it to percentage number like for example 42% in this case. So let's look at another example here. Here is the transmission of power from the power plant to a lamp in the house. Okay, so if you look at it very carefully, there are three systems here actually. One is the power plant, one is the power plant, one is the transmission cable, and one is where the electrical light bulb is trying to make use of the energy. Okay, so at the power plant there, the purpose of this power plant actually is to generate the energy from the coal, indicated here coal, or probably hydroelectric, but in this case it's coal, that initially it has 100 unit. Okay, initially it has 100 units. That's the input in this system. Power plant, it loses 62 unit, and 38 unit enters the transmission line. Okay, so with these numbers given, 100, 62 and 38, the efficiency we can actually get by using the 100, which is the input, and then on top here we should put the 38. Okay, because that is the useful, that is the purpose of this power plant, is to generate the power to be transmitted. So 38 enters means that 38 is the useful amount. All right, so probably you can now try to figure out what is the efficiency of the transmission line and what is the efficiency of the light bulb. Okay, you pause the video before I show you the fraction. You can leave answer in fraction like what I did for the first case there, the power plant. Okay, let's pause the video and then you figure out. Alright, so for transmission line, because the losses is 2 unit, therefore it will have 36 unit indicated down here, so 36 unit. So 36 unit out of 38, because that's the amount that enters. So the fraction basically is 36 divided by 38, right? Whereas at the light bulb here is 2 divided by 36. The 34 is the unwanted ones, okay, unless it's a heater. Okay, unless it's a heater, then we use 34, but because this is a light bulb and we want to get light out of it, so the useful amount is 2. So 2 divided by input, the 36 unit. Okay, so let's move on to one example here. Okay, it asks what is the power output of the motor. So what the motor did is it pulls the cable, and is pulling the cable at 4.8 meter per second. It pulled the cable at 4.8 meter per second, and it has a force, it apply a force of 8,500 meter. Therefore, we can say that the power is Fv from the earlier of this topic. So you have 8,500 multiplied by 4.8. Alright, next part of the question. What is the efficiency of the output of the motor if the input is 60 watt? So then we apply efficiency is the output divided by the input. Then we get the answer from the A and divided by 60K. Then you should be able to get the answer here. Next, we have an electromotor is trying to power a pump. It leads 200 gram water through 2 meter in 2 seconds, and it is moving out at 1.6 meter per second when it exits. Okay, what's the output power of the motor? So again, we look at what's the purpose of this motor. It is to lift the water. Okay, so we cannot use F times V here because we don't have these quantities, whereas we can use the definition of power instead, which is energy divided by time. So energy here refers to the energy that the water gain, the total energy that the water gain because the pump is trying to give to it per unit time. Okay, so then you think about what is the amount of energy that it gained and what type of energy is that. So according to the information here, the first type is supposed to be of course it's the gravitation potential energy. So we have the mgh, and also we are told that it is moving out at 1.6 meter per second. So which means that it actually gained this amount of kinetic energy at the end, where you can assume that it is not moving at first at the bottom of the tank. Okay, so divided by the time taken, right, then you should be able to get the answer. The next is you are given that the input power is 3 watt, and what's the efficiency? So similarly here, efficiency, just write E, it's okay, is 3, which is the input. Then you get answer in A here. Then you should be able to get the answer. Okay. So next is an exercise that you have it in your handout. So that will be the assignment for this topic. Okay, so it has 2 parts actually. I'm not going to show here, it's too slow.